Does it move now? Yeah. Okay, let's go through this. Okay, we are saying that the zeros, okay, the zero of any polynomial are those values for which the polynomial is equal to 0, or in other words, the point where the graph cut the x-axis. So in here we had how many zeros? We got 2 0. In here, if you continue with this line, well, we're going to have 1 0, and in here we're going to have 3, and in here we're going to have 4 zeros. Okay, that's all what it is. Okay, so when people talk about finding the zeros of a polynomial, that's what they meant. Okay, so it's just to find where the line cut the x-axis. Because sometimes we have situations in which it doesn't cut it at all. Okay, node, we're going to say. Node, if a polynomial is completely factored into linear factors, then it is easy to graph fit. Okay, so this is important because this is telling you that if you can factor a polynomial into linear factors, then it's going to be very easy to see what to do when sketching them. I'll give you an example. Sketch. Example. Sketch the following polynomial. Hi, number 1. Number 2. Okay, let's say that the question in test is to sketch these two polynomials. Okay, solution. We're going to sketch this polynomial. Can you see that the degree of this polynomial is a cubic? Because we're going to have x times x and then times x again. Okay, so it's going to be a cubic. So you already know that it's going to look something like that, right? Okay, but the first thing that you have to do is find the 0. So we're going to say to find the zeros. We do as follows. By the way, you can see that this polynomial is completely factored. Okay, so we don't need to do any other factorization. So it's already done. Okay, so to find the 0, we do as follows. So we made that equal 0. So we made the polynomial equal 0. Yeah, x plus 2. Okay, and then we're going to break these down into 1, 2, 3 factors like this. So we're going to say x equals 0. And then we're going to have x equal to 3. And then we're going to have x is equal to minus 2. Okay, so you do x equals 0, and then you say x minus 3 equals 0, so therefore x equals 3. X plus 2 equals 0, so therefore x equals negative 2. Okay, and then we are ready. And then we draw the number plane. And then we plot this. So we're going to have 0. Here we're going to have negative 2. And here, let's say, there, positive 3. And because this is a cubic, we know that the answer is going to be something like this. Okay, so it's going to look like that. Okay, later this year, you are going to learn how you find this point. Okay, and then we're going to also see how to find the point where it changes concavity. So, yeah, you are going to learn all that stuff later.
Does it matter how bad your D looks, the curve?
Mm-hmm.
You know the curve? Does the orange line?
Yep.
Does it matter how neat it is?
Well, make sure that it looks curvy. Okay, it's not a straight line. That is, yeah, so it must look curvy. Especially in tests, because if you say that the answer is straight line like this, then yeah, it doesn't make sense.
If you show us how to find that point, we'll have all different.
Yeah. Okay, so this is only a draft copy. Okay. Yeah, because this could be higher or lower. We don't know. Okay. For now, all what we know is that it looks something like that. Okay. Let's do the other one. Okay, the second one, what sort of polynomial is this one? Quarty, okay, because we're going to have x times x times x times x. If you expand this, you should do that, and then the higher power is going to be 4, so it's a quarty. Okay, and then you do exactly the same. Okay, so we find 0, so okay, so we set up this to be equal to 0. And then we break up this into factors. So you're going to have x equals 0. And then if you want, you can say x plus half equals 0. X minus 1 equals 0. And then x plus 2 equals 0. And then you solve. So that will give you x equal to negative half, x equal to positive 1, x equal to negative 2. Okay, and you can see that you have, in this case, we have 1, 2, 3, 4 zeros. And then we sketch it. When sketching in tests, the standard size is about 1/3 of an A4 paper. Okay, that is the standard size. Okay, you don't have to do very small graph because it's hard to see, and you don't have to do a big one. It's no need. Okay, so it's about 1/3 of an A4 paper in test. Okay, make sure that you do that. Okay, so we're gonna plot the points. So we have 0, we have positive 1, we have negative 2, and we have negative half. this, and then you do the picture. Okay, so we know that when you have the coefficient of x is positive, can you see that when you multiply this, times this, times this, times this, then the coefficient is going to be a positive number? Okay, because you are not multiplying x by any negative thing, so it's going to be x times x is x squared, and then x squared by x is going to be x cubed, and then this by this is going to be x to the power 4, so it's going to be a positive number. And because of that, then the picture is going to look like a w. All right, so it's going to look something like that.
Does it matter in what order it goes negative half, then 1, then negative 2?
In here,
Yeah.
it doesn't matter as long as you plot them correctly along the line. Yeah, yeah.
But does it mean anything like eventually? Or
No. Okay, so you can see sketching polynomial when they are in factor form is simple. The problem is when you have a polynomial given in the general form, and then you need to factorize it. Okay, so that is a different thing. Okay, let's do another one, and then you're going to start doing some of them by yourself. All right, by the way, I need to do something else. Okay, we're going to say now, consider the following polynomial. Okay, so in here we have x in bracket minus 1, and then x plus 2, but then you can see that we have a square in here. When we have a situation like this, we're going to say this. So we say that this polynomial has a double root of 0 at x equal -2. Okay, so if you have a picture like this, or if you have a polynomial like this, then we say that we have a double root at x equal -2.
Always x equals
No. Well, depending on the equation. So if you have x plus 3, then you have a double 0 at -3. So in here, if you have x minus 1, then you have a double root at x equal 1. Okay, what happens when you sketch things like this? See what happens. Okay, so if you find the 0 for this one, you're going to have 1. Okay, 1 is going to be 1 over 0, and then -2 is going to be the other one, and then we're going to have another one which is also equal to -2. So we have -2, and in here we have +1. And what sort of picture is this one? What sort of polynomial? What is the degree? It's a cubic. Okay, so it's going to be a cubic again. Okay, but having a double root means that this polynomial is going to touch the x-axis up to, and then it's going to cut the x-axis at +1. Okay, so we're going to have a situation like this. So when you have a double root in a particular point, it means that, you know, the curve is not cutting the x-axis, but is touching it at that particular point. Okay, let's see what happened to this one. Px is equal to, let's say that you have this, x plus 3, and then you have x minus 1 square. Okay, first of all, you're going to tell me what sort of polynomial this one. Is this a quadratic, cubic, or it's going to be quartic? And the reason why, because this is square, and then a square multiplied by x, that will give you cube, and then when you multiply cube by the other x, it's going to be to the power of 4. All right? Okay, so we know that we have how many zeros? So we're going to put the 0. So zeros, we're going to have x equal 0 is going to be the first one. And then the other one is going to be x equal -3. And then we're going to have a double 0 at x equal 1. So we're going to have x equal 1. And then we're going to have x equal 1 again. Okay, still we're going to have 4, but 2 of them are identical. Okay, that's all what I mean. And then to sketch this, okay, so we're going to plot the point first. So we're going to put 0 and then -3 and then 1. Okay, and then we have the double 0 in here. Okay, so we got to be aware that that is where we have the double 0. And also we know that this is a quartic, so it behaves something like that. Okay, so we're going to go do this like this, and then we're going to go like this, and then go like this, and then it go up like that. Okay, now you're going to do one by yourself.
What was that one called you just did?
Sorry?
What was that one called? Is that mirror diagram?
This one
Yeah.
is a quartic. Okay, so quartic. Because when you multiply the x's, so in here you have x squared, right? And in here, if you multiply x squared by x, it's going to be x cubed. But then if you multiply x cubed by the other x, it's going to be x to the power of 4. Okay, and we call that quartic. Okay, what happened if you had this one? Okay, can you please sketch that one? No, it doesn't have to go through 0 all the time. Okay, so all depending on the roots of 0. Hmm? Well, let's see. Okay, so zeros. So you say x plus 3 equals 0, x minus 1 equals 0, x plus 5 equals 0, and then we have another x plus 5 equals 0. So this implies x equal negative 3. This implies x equal positive 1. This implies x equal negative 5. And then the other one also go there. Now, does it go through 0? No. Okay, obviously not. Okay, and then you do the picture. Okay, so we plot the zeros. So we got negative 3, 1, negative 5, and negative 5. So negative 5, let's say, is in here. Negative 3 in there. And positive 1. Okay, and then we're going to mark the point where we have the double 0. So we have the double 0 here. And this is another quartic. Okay, so it's going to be another sort of W. Okay, but it's going to go like this. So it's going to go like that. Touches in here. Then come down. And then you go all the way up to 1. Alright, so it's going to look like that. Okay. Okay, let's do 2 more. And then you're going to start doing the exercises from the textbook. Okay, so first we're going to find the zeros. To find the 0, we set each one of these factors equal to 0. So we're going to say minus x equals 0, and then x plus 4 equals 0. Right? Okay, so we set that equal to 0, and we set that factor equal to 0. And therefore, well, this is simply x equals 0, and this one is negative 4. Okay, so we have 2 of them. But then we're going to be careful. We've got to be very, very careful. If you expand this, okay, if you expand this, can you see that the number in front of the x is going to be a negative number? So if you multiply negative x times x, it's going to be negative. Okay, because it's negative, then the picture will flip. By the way, this is a parabola. Can you see that if you multiply this by this, it's going to be square? So we know that originally it should look like that. But because of that negative, then it will flip. Okay, so that means that we're going to have 0, negative 4, but then it's going to look like this. Yeah. Okay, do the next one. Okay, for the next one, again, you've got to be careful because you have a negative in front of the x in here. Okay, and we have a double root at negative 2. Okay, and this is another quartic. Okay, see if you get the right picture for that one. And then when you finish, you're going to do exercise 28.2. From here, I'm going to give you a hard copy this time. Okay, so you have a copy. The very popular Sarah, one for you, and Harrison, unique one. Give me 1 second. Yes.
So how do you turn negative 2 x into? Do you just multiply inside by negative 2?
Yes, I show you. You do exactly the same. Show you. Okay, so 0. Okay, so we're going to set up each one of these factor to equal to 0. So we're going to do minus 2x equals 0. So that will give you x equals 0. Okay, because if you want to make x the subject, well, you divide by negative 2, so it's 0. And then we're going to have x plus 2 twice. X plus 2 twice if you want to. Okay, so that will give you x equal negative 2. And that will give you x equal negative 2. And finally, we got x minus 3 equals 0. So that will give you x equal positive 3. Okay, and then, yeah, you plot the points.
Did you just add that little square?
Yeah,
He added it late. Oh.
Yeah.
Well, I did it without the little square.
Ah, right, okay. Okay.
Does it still look the same anyway?
No, because, yeah, if you take these 2, then it's not a quartic anymore. So it's going to be only a cubic. But from the moment that you put 2 there, then, yeah.
But I'd already written it down.
Do it again. Yeah. Do it again, because, yeah, the picture changes. All right, and then you're going to start doing exercise 28.2, okay? And then next lesson, we're going to go through something that we call the remainder theorem, and then we're going to do something that we call the factor theorem.
Wait, can you do that one on the board?
The picture? Yeah. You're going to start now, yes. Okay, Sarah, so we have 0, so we're going to put 0. And then we have negative 2 twice. Okay, so let's say negative 2 is where we have the double root, and then we have 3, so it's going to be somewhere here. And it's going to be another a w, okay? Actually, it's going to be an m because it will go down because of this negative. So that means that we're going to have something that looks like this. It's going to go like this. We have the double, And then we got that one here. And then we got that one. Okay?
That's what I had.
Okay, so you can see that when the equation is given like this, it's sort of simple. Okay, so what you have to do is to identify, the 0. So you put the 0, and you have to see whether you have a double. If you have a double, you know that it will touch.
If it wasn't double, that line, instead of curving and touching to 0, just straight up.
Yeah. Yeah. Yep.
Yeah, we were just saying to a cubic rather than a quarter as well.
Right. Do you have any question?
How do you do question 3?
Question 3 from 2. Okay, so you're talking about question 3 from page 218?
Yeah, the lots of writing.
Yeah, sometimes you have a lot of writing, but the writing say a lot of stuff that sometimes is not necessary. But look at the picture. Okay, so this is the polynomial. So you have x minus 1 and then x plus 2 square. Okay, so you already know that you have a double root at x equal -2.
Yeah.
Okay, so you find the 0, 0.
But wait, what are you doing on the question? Because it already has the graph.
I want you to draw in more detail because that's a rough sketch or something.
Okay, read the question. Read the question, take your time.
To myself.
Mm-hmm.
So we're just drawing.
Yeah, so you're going to draw in, but I think that what they meaning here is to put some additional point.
X equals -2.
Yeah, so you're going to do a little table of values. Okay, so you're going to do a little table of values. And you're going to go, let's say, -2, -1, 0, and 1. And then you're going to have the y values. And then this together with the information coming from here, obviously you're going to have a more accurate picture.
Wait, how do you get the...
Because whatever that equals is what the y value will be.
Yeah. So in here you substitute. So if you want to find this y value, you substitute x equal -2 in here as we done all the time when sketching. Okay, you substitute, put that in your calculator. So where x is, put -2. Again, then you're going to find these values. Okay, and then this together with this will give you a more accurate picture. That's all. That's all what they
And
want.
do I draw another graph?
No, do the graph.
Yes, I do another graph.
No, do only one graph, but use this table together with this.
I do another graph from that graph on this.
Okay, so if you want to, why not?
No. Okay,
Okay, we're done. Yes, please make sure that you do the question from here. No, you're not going to do question 8. So you're going to do question 1 to up to question 7, but you're not going to do question 8, okay?
And 9, we're not doing on the 9.
No. So you're going to stop
so just do that.
in question 7. Yeah, do that page.
Do 1 to 7.
1 to 7. That's all what you have to do.